So we have two conditions of similar polygons or similar triangles specifically for this lesson. Corresponding sides are proportional. Someone's talking over me again. What about corresponding angles if you remember from last time? Corresponding angles must be what? Congruent. So I'm going to go straight on to example number 1. On example number 1, how many triangles do you see? I see a small one, I see a middle size, and I see 3 as a whole. Okay, so let's see what that means. My small one is to the right, and then my middle size is to the left. It's larger than the one on the right. And then we have the biggest one as a whole. And something is true about this one at all times. And I'm going to actually prove that to you with an image. How did I put this? That way. Uh-oh. This way. This way. No. There we go. All right, here's my proof to show that they are similar. Y'all ready? Okay, eyes up here. If I give you one right triangle, and these are overlap for a reason, and I create an altitude, it makes 3 similar triangles. And how would I write this or put this? Here's 1, here's 2 that I'm going to line up, and here's my 3rd one. They are similar. Another way to look at it, I can overlap them on all the right angles, and all the lines that it creates right in between will be parallel and proportional. Okay? So, given that, let's put in everything we know about the triangle given on the right side. I want you to put in small figure, then we have the large figure, or short leg, long leg to hypotenuse. So let's look at the small image. What do I know about the small image? Small image has short leg of what? Ooh, is that the x or is it the 8? 8. And then my x would be the long leg. Now let's go to our pink triangle. In the pink triangle, who is my short leg? Oh, short leg, the x. 18 is my longer leg. Now, because I can make a little proportion, meaning I could make a box, I do not have to analyze the big triangle at all. So let's go ahead and make our proportion. We have 8 over x is equal to x over 8. And I'm going to mention that something that we did last week. Maybe this was not mentioned. When you have x across from each other and they're identical, that's called the geometric mean. So if I ask you to find the geometric mean and you do not have variable across from each other that's identical, you've done something wrong, okay? So let's go ahead and do our math. Again, you don't need a calculator for this one. X squared is equal to, well, that should be 18, right? Did you guys notice that? Yeah. So we have 8 times 18 is going to give us 144. And then we are going to square root. Because we're square rooting a perfect number, we have x equals how many? 12. Put a big star on this one. There's a reason behind this. Because I gave you a picture, your number has to be positive. But let's think about what y'all did in Algebra 2. When you were square rooting on both sides, did we have one answer or really 2 answers? 2, what were they? Plus or minus 12. That would happen if I do not give you a picture. So let's say on your text next time, and by next time, next week for us specifically, I give you just the equation. So no picture, just the equation. Your answer is this. Let's say I give you a picture. Your answer must be the positive value only. Remember that, okay? So let's go ahead and try example 2 with the partner. So decide on what 3 triangles do we have and label short, long leg, and hypotenuse and fill in what you know. You do not need a calculator.
I don't know how to back.
Simplify the radical. Let's see if you at least started the same way. Did you label short leg, long leg, and hypotenuse? In my small triangle, I only have one item given, the short leg of 5. Is everyone okay with that?
Yeah.
Okay? I don't know the other information. In my pink triangle, I know my long leg is 15, hypotenuse is x. And then in my big triangle, the long leg is x. Hypotenuse is actually how many? 20. So the only place that I could make a proportion is right here. Meaning sometimes there may be extra information that you don't need, which is perfectly fine. So let's go ahead and write out our proportion. 15 over x is equal to x over 20. Are we on the right track?
Yes.
And we know that because what is across from each other? The x's, identical piece. So when I cross multiply, we get x squared is equal to 300. And we need to simplify the radical, which is fine. I see this as radical 3 and radical 100. Isn't this a perfect square? Of what? So we have 10 radical 3. Could you have split it in a different way and still get the same number? Definitely. Now, should I say plus or minus 10 radical 3 or just positive 10 radical 3? Because we have a picture. Very good. Let's jump to the bottom. Jet, let's read. What is?
What is the geometric mean of 4 and 25?
So we're looking for geometric mean. So we know we have to put x diagonal from each other as if you were cross multiplying. Doesn't matter where I put the 4 and the 25. No. Top, bottom, doesn't matter because in the end we're going to cross multiply. So I'm going to write 4 on the left, 25 on the bottom. Now when I cross multiply, we get x squared is equal to 100. Do I have a perfect square?
Yes.
So x equals 10, done.
No.
Why is that?
You gotta do plus five.
Because we don't have a picture. Very good. Look at you guys.
I got it.
All right, Jack, read the second one. 12 is.
Oh, 12. Wait, Jen or Jen?
Jack.
Oh, okay.
George?
12 is the geometric mean of 8 and what number?
So now we know the geometric mean. So my x's are not my geometric mean anymore. So that means my 12s are across from each other. So something has to be the same. Typically, they're the x's, but it could be the numbers as well. Does it matter where the 8 is going to go? No, because in the end, we're going to cross multiply. So when I cross multiply, we get 8n is equal to 144. And then when I divide it by 144, which I did a while ago, should be how many? 18. Does this one need plus or minus?
Yes.
No, we're now square rooting on both sides.
George? Guys, I'm sorry.
It's okay. All right, when you're ready for the back page, give me a thumbs up. Ready? Ready? All right. I'm going to take example 4A in the easiest way possible. So, George, let's read 4A.
Using the diagram at the right, what are the 3 geometric means?
You can make your proportion as many times as you want, or take my method that's going to work out every time. You pick the vertex of the right angle, Jack, of the big triangle, put a big fat dot. And whatever stems off of that is your geometric mean, no matter what. So we know ED, EG, EF. Always, always, always. Do not have to separate it. Don't need to put in variables. That's always going to work out. All right? So the next piece. Let's write out our similarity statement. We have a triangle something is similar to. Triangle something is similar to. And my third triangle. Doesn't matter how you order the triangle initially. It doesn't. But whatever you initially make must be consistent on the other one. So let's say I start the small triangle with D, G, E. If I go from D, G to E, so short leg to the right angle to the long leg, how would I order that for the middle size? I haven't heard the right one yet. Mm-mm.
F, G, F, E.
If I'm going from D to G, which goes to the right angle, to the long leg, this one should be E to G, G to F, EGF. And then on the big one, it's going to be DEF. So now let's skip to example number 6. Lawrence, let's read example number 6.
The altitude of the right triangle divides the hypotenuse into segments that are 8 centimeters and 10 centimeters long. Find the length of the altitude.
So the altitude is dividing. So that means I want to put the altitude on the top somewhere, right here. It's easier when I'm dividing to drop it straight down. So let's drop it straight down. Here's my altitude. So this is dividing this segment down here into 8 and 10. So from here to here must be 8. From there to end point must be 10. And it says find the length of the altitude, which is what I drop down. Didn't we already practice a bunch of these with the geometric mean triangle?
Yes.
So I'm going to leave it right there. I just want to show you how to translate the word problem into our picture. Everyone good with that? Okay, what's up?
If we were to draw a picture like that, would it still be plus or minus? Since we didn't.
Since you gave me a picture, it'll just be a positive. Okay, good question.